Hello, this lesson is on partial fraction decomposition. So partial fraction decomposition is when you have a rational expression like this and you want to split it up into two rational expressions that are added or subtracted. And so there's a partial fraction decomposition form that we use. So this rational expression is going to equal a over factor 1 plus b over factor 2. So that's the partial fraction decomposition form. Okay, so if the directions say write the partial fraction decomposition form for the following, then rewrite each as a partial fraction, this is what you're going to do. So step 1, you're going to factor the denominator if you need to. And so x squared minus x minus 20 can be factored into x minus 5 times x plus 4. Okay, so this rational expression, the partial fraction decomposition form for it will be, you're going to put the letter a on top of one of the factors plus b on top of the other factor, x plus 4. And our job is to find the values of a and b. So the way we're going to do that is we are going to multiply this equation, and it's really important to write the left side and the right side because you're going to multiply the equation by the LCD, and the LCD is always going to be the denominator because you're going to pick up factors that you want to cancel. So there's an x minus 5 factor and there's an x plus 4 factor. So you're going to multiply both sides by x minus 5 times x plus 4. And the goal of this, multiplying by the LCD, is to get the fractions away, divided out. So x minus 5 times x plus 4 divides out with x minus 5 times x plus 4, and you're left with x plus 2. And remember, you have to distribute the LCD to both. So a over x minus 5 times x minus 5 times x plus 4, the x minus 5s cancel. All right, so you're left with a times x plus 4 plus b over x plus 4 times x minus 5 times x plus 4. The x plus 4s are going to cancel, and you're left with b times x minus 5. Now, you're going to use this new equation that you've created a couple of times to find the value of a. All right, so step 4, you're going to use this equation. What we're going to do is we can let this value of x here, because we're looking for a and b, we can let x be any number we want. So we're going to be kind of clever about it, and we're going to let x equal one of the zeros. So x plus 4, if you set that equal to 0, one of the zeros is x equal negative 4. Right? So we're going to let x equal negative 4. And we're going to substitute negative 4 everywhere you see x. So that would be negative 4 plus 2 equals a times negative 4 plus 4 plus b times negative 4 minus 5. Okay, and so on the left side we have negative 2. And watch what happens. Because we picked negative 4 as our 0, that a times 0 is gone. And so all we have is negative 9b. We want to solve for b, so we're going to divide both sides by negative 9. And we're going to get b equals 2/9. All right, now the method we just used there, we're going to use it over again because we have another 0. So x minus 5 equals 0, that would give you a 0 of 5. So we're going to let x equal 5. I'm going to take this equation that I put in a box and use it again. So I'm going to put 5 everywhere there's an x. So that's 5 plus 2 equals a times 5 plus 4 plus b times 5 minus 5. And so we get 7 equals 9 times a. B times 0 is gone. And that allows us to solve for a. So a is 7/9. Okay, now we know what a and b is, so we're going to write this expression in its new form. And I'm glad these are fractions. If they're fractions, you can do this. Instead of putting 7/9 in for A, you can put 7/9 and let that be A times x minus 5 plus, same thing, instead of putting 2/9 in there for B, we can put the 2 in the numerator and then the 9 in the denominator with x plus 4. So x plus 2 times x squared minus x minus 20 is equivalent to 7/9 times x minus 5 plus 2/9 times x plus 4. So these fractions don't always happen, but if that happens, if A or B are fractions, you can put the numerator of A in the numerator and the denominator of A in the denominator with the factor. Okay, so we're going to take a look at number 2. Step 1 is to factor the denominator if necessary, and this one is not, you don't need to, it's already factored. So we're going to go ahead and write the partial fraction decomposition form, and it's going to be A over one of the factors, x plus 5, plus B over x minus 3. All right, so then we're going to multiply by the LCD, and the LCD is always going to be this x plus 5, x minus 3. So if we multiply each of these by x plus 5 times x minus 3, it's going to help us cancel out the fractions. All right, so x plus 5x minus 3 is going to divide out with that. That leaves you with 7x minus 1. Here, the x plus 5's cancel, and that gives you a times x minus 3. Plus, here, the x minus 3's cancel, and you have b times x plus 5. And that's the equation we're going to use to find out what a and b are. Okay, so we're going to let x equal one of the zeros. So the zero that comes from this factor, x minus 3, is 3. So we'll substitute that in everywhere we see x. Okay, that's 21 minus 1, that's 20, equals 3 taken away 3 is 0, so a times 0 is gone. And then b times 8, so b times 8 would be 8b. Okay, so we're going to divide both sides by 8. And so b equals, 4 goes into both of those, b equals 5 halves. All right, we're going to do the same thing. This time we're going to let x equal this 0. The 0 that comes from that factor would be negative 5. And we're going to substitute into this equation. So that would be 7 times negative 5 minus 1 equals a times negative 5 minus 3 plus b times negative 5 plus 5. So 7 times negative 5 is negative 35 minus 1 is negative 36 is equal to negative 8 times a, and that's 0. So if we divide both sides by negative 8, we get a equals, a negative divided by negative is a positive, and 4 goes into both of those, so that's 9 halves. So again, we have fractions. Okay, so what we can do is we're going to go back to this partial fraction decomposition form right here, a over x plus 5 and b over x minus 3. See that? So we're going to have 9 over 2 times x plus 5 plus 5 over 2 x minus 3. So I'm just putting it back into that partial fraction decomposition form that we started with. Okay, let's do another one. So number 3, we have to factor, and there is a GCF that we can pull out. So this is x minus 8 over x times x plus 2. See that? Equals, and then the partial fraction decomposition form will be a over one of the factors, so a over x plus b over x plus 2. So that's why we have to factor first. Okay, then we're going to multiply through by the LCD, and the LCD is always going to be that x times x plus 2. All right, so that x times x plus 2 in the numerator cancels with that in the denominator, and you're left with x minus 8. Here, this x and this x cancel. You'll be left with a times x plus 2. Here, this x plus 2 and that x plus 2 cancels, and you are left with bx. Okay, so this is the equation that we're going to be using. So now we're going to let x equal first 0. If x is a factor, then 0 is a 0. We'll let x equal 0. We'll plug it in. 0 minus 8 equals a times 0 plus 2 plus b times 0. So that gives you negative 8 equals 2 times a. So we divide by 2, and a equals negative 4. All right, now we're going to let x equal the other 0, so that would be negative 2. And plug it into this equation. So that's negative 2 minus 8 equals a times negative 2 plus 2 plus b times negative 2. Okay, so that's negative 10 equals, it's gone, negative 2b. You divide by negative 2, and b is equal to 5. So now we'll go back to that partial fraction decomposition form, and a is negative 4 over x, and b is 5, and it was over x plus 2. All right, let's try this last one here. And this one is the toughest one, so we're going to need our calculator. So first, we have to factor this denominator. And the first thing I see is that you can pull an x out. So that's x squared minus 9 times x. And then that factors again. So it's going to be 11x squared plus 21x minus 18 is over x times x squared minus 9 factors into x plus 3, x minus 3. Okay, so this time we have 3 factors in the denominator. So what do we do then? Same thing, we're just going to add a letter. So we're going to have a over one of the factors, so a over x, plus b over another factor, so b over x plus 3, plus c over that third factor. And we're going to multiply by the LCD just like we did last time. So that LCD is going to be x times x plus 3 times x minus 3. X times x plus 3 times x minus 3. And remember, the whole reason we're multiplying by the LCD is to cancel out the denominators. So that x times x plus 3 times x minus 3 in the numerator divides out with that in the denominator, and that leaves us with 11x squared plus 21x minus 18 equals. Now we're going to distribute that to all 3 with the idea of canceling. So this x is going to cancel with the x, and that's a times x plus 3, x minus 3, plus this x plus 3 cancels with the x plus 3, but the x and the x minus 3 are left. So that's bx times x minus 3, plus, and this c, this x minus 3 is going to cancel with that x minus 3, but it's going to leave those other 2. So you'll have c times x plus 3. So that is the equation we're going to use. We're going to have to use it 3 times this time. Okay, so we're just going to pick the zeros as our x value. So I'm going to let x equal 0 first. So if I plug 0 in here, I'm going to get 0 plus 0, and then a negative 18 equals a times 0 plus 3 times 0 minus 3, plus, if I put a 0 in here, that's going to go away. If I put a 0 here, that's going to go away. So that's it. So that's negative 18 is equal to 3 times negative 3, or negative 9a. So if we divide by negative 9, we get a is 2. Okay, now we're going to let x equal the second 0. So x plus 3, that's going to give you a 0 of negative 3. And that's what we're going to plug in here. And this is where I'm going to need the calculator. So I've got to plug negative 3 into 11x squared. So that's going to be 11 times, calculator on. All right, 11 times negative 3 squared plus 21 times negative 3 minus 18. And that gives me 18. So when I let x equal negative 3, this left side is positive 18 equals, okay, now if I put negative 3 into this 0 right here, that a is going to go away. All right, and if I put negative 3 into that 0, that c term is going to go away. So I'm just going to use the b. So b times negative 3 times negative 3 minus 3. And that's 18 equals negative 3 times negative 6 is 18b. So if I divide by 18, I'm going to get b equals 1. All right, we're going to do this one more time. So we're with our third 0. X minus 3 gives us a 0 of 3. So I'm going to let x equal 3. And I'm going to put 3 into this left side here. So I'm going to do this again. So 11 times 3 squared plus 21 times 3 minus 18 gives me 144. So the left side is going to be 144 equals, all right, if I put 3 into this a term, this 3 take away 3, that's 0. If I put 3 into this term, that's 3 take away 3, that's 0. So that term is going to multiply out at 0. This one's the only one that's going to stick around. So that's c times 3 plus 3, which is 6. So we're going to get 144 equals 6 times 3, 18c. All right, 144 divided by 18 is 8. So we get c equals 8. So the last step is to take these 3 and put it into the partial fraction decomposition form. So a is 2. It goes with the factor over x. b is 1, so that goes over the x plus 3 factor. c is 8, so it goes over that x minus 3 factor. So that's the partial fraction decomposition form for that rational expression. Okay, so you have 6 to try in the back. Come back and check your answers if you'd like. Okay, so if you did all of these, hopefully you were successful. I'm going to focus in on 4 and 6 because they have some zeros that are fractions. But check your work. Here's 1, here's 2, here's 3, here's 4, here's 5, and here is 6. So let me talk to you about 4 and 6. So first of all, they were harder to factor. So hopefully you were able to factor. And one of your factors here is 2x minus 1. So to find the 0 that goes with that factor, you have to set 2x minus 1 equal to 0, and you get x is 1/2. And so just use your calculator. 3 times 1/2 plus 31. No, that's 3 times 1/2 is 1.5 plus 31 is 32.5. And then 1/2 in here, that's 0.5 minus 7. That's negative 6.5. And divide, and you get a is negative 5. So that one wasn't too tough because 1/2, you can think of as 0.5 if you'd like. However, be careful here. Look at 6. So if you were able to factor that correctly, you get 3x minus 2 for one of the factors. And when you solve for set it equal to 0 to find the 0, you get 3x equals 2, and then x is 2/3. And you cannot use 0.67. That's not an exact number, and it won't give you the exact nice answer that you get. So just use your calculator, and you're going to put 2/3 into this, in for x. And so what happens is when you put 4 times 2/3 plus 44 in your calculator, you want to hit math fraction, and what you're going to end up getting is 140/3. All right, equals, and then when you put 2/3 here, if you use your calculator, you're going to get 14/3 times a, and then that goes away. So you have to remember how to solve 140/3 equals 14/3 times a. Well, you can multiply by the reciprocal, 3/14, and this is why we like fractions. See, the 3's divide out, you get 140/14, which is exactly 10. So if you use 0.67 instead of 2/3, you're not going to get exactly 10. So that's important to use the fractions instead of the decimals when you have to round the decimals. Okay. See you next time.